Greetings, I'm Kitty Hut and my teammate Patit from Orange team of Princess Julapon Science High School Shubli. The topic of target of interest systems, third body observation, we are transiting exoplanet survey satellite database with our advisor and supervisor, Mr. Vishen and Dr. Subshai, respectively. Due to the limit of astronomical resources, most of astronomers decide to use the high-efficiency ground telescope for observation. Therefore, one of the methods to detect exoplanets is such high budget, which is radiography. Normally, we will use transit photometry to check first. However, we have an idea that if there are some methods close to our interest target, it will have an interaction to each other from the gravitational force and transit graph will be relation graph. I will call it TTV. So if I can detect relation graph, it may have third body in the system that we expect exoplanet status. For its objective, first to determine the existence of a third body. Second, the article shall serve as reference data. Third, to construct an instrument for observation of celestial objects. And fourth, to serve as inspiration for youth. And yeah, for experimental method, initially we study from theory, expanding with if there are some barrier obscure by sort, intensity will decrease. In the same case of exoplanet and host star, we will get transit graph, but in reality, transit graph have curve in drop of light dilation that caused by Lindemann effect. We will try this experimental with least square method in astroimagery first and develop into Markov chain multicolor encoding and explore about the other methods in TOI system that is our target. First, light curve module. Download dataset from exoplanet.eu and use the light curve module to looping in each name, sector, and expected time. After that, we will split continuous graph to partial graph and save as .xlsx. And secondly, install transit feed module to do best parameter by co-effective temperature, metallicity, and surface gravity, and run it. Next, we will check the efficiency compared to NASA pipeline by find coefficient of relation between base and original parameter. Lastly, we will write new code by PyAstronomy and use generalized Looms cargo to do Fourier transform to find the possibility of detection and do opacity diagram to find the mass of third body by this equation, which we assume J is equal to 1 currently to use. For result and discussion, many of observation we get one evidence from 293 by using astroimagery. We found that it has large gap between original and fitted parameter and consider that least square and iterative method in astroimagery may not detect small signal because TOI 3288.01 is only one that have large signal according to data base of NASA, not in Brazil. And for this table, we will see by using Markov chain multicolor for analyzing its more efficiency if we compare it to NASA by we find one of three parameters that is high from other that is inclination, but the reason is astronomer estimate it equal to 90 degree. It is easy to use that. Lastly, we make the same parameter if use the Markov chain multicolor method. Next, the upper figure will show continuous of transit graph. You will find the variation of mid-transit time, and below the right side is the partial of above. And we detect the interest third body from TOI 193.01 that have parameter amplitude 1.5 minutes, highest power period 5.98 epoch, and mass is around 0.022 times of Earth mass, and the possibility of detection around 15 to 20%. And in conclusion, can conclude that Markov chain multicolor are more appropriate to use instead the transit graph than least square method, and transit fit have high quality and can compare to NASA pipeline class. And lastly, third body in TOI 193.01 masses approximate 0.022 times of Earth mass and have 15 to 20% to be true signal. Thank you.